We've all heard the saying, time is money. This adage is especially true in the financial sector. Whether you're analyzing your stocks or your ETFs on a 5 to 10-year horizon, or you're engaging in fast paced cryptocurrency algorithmic trading on a minute by minute basis, the time parameter is always at the heart of financial analysis. That's why in this chapter of our Python for Finance free course, we're exploring how to analyze time and sequence it and produce a solid technical analysis based on it. You can find this chapter 8 on our website. The links are below. So let's not waste any more time and dive right into the heart of the matter. So let's create a Jupyter notebook for this chapter. So chapter 8, I, Pi, and B. Then we can always do a little print, let's say a print hello, just to check that everything is running fine. Let's do that. Okay, we're all good. So the package we're going to be using, the important package, is Datetime. So we should import it. Since this is actually a native Python package, so there's no need for you to install it. It's already included when you install Python. And this is what is really going to enable us to do a lot of intricate date manipulation and time manipulation today. So let me do a first illustration by printing today's date using datetime. So I'm going to do print datetime, use the method called, or the function called date. And here, if I want to have today's, let's say the date of that I'm recording this video. So you always do the year first, then the month, and then the day. So that's it. So let me print that. Okay. A little subtlety, we shouldn't put the 0. I had forgotten about that. Let's run it. And there we go. Okay, so what we see here, cool, we see a date. And you might be wondering, why did I not simply, if I wanted to print the date, why did I not simply do this, like put it as a string and print it here? And you see, we see exactly the same result. But here's the thing, a string here, if I tell to Python, take this string and say, add 2 days to that date, well, it's not going to be able to do anything because it's a string, so it doesn't really know what's in there, etc. But the point of using this date time is that now it understands that it is a date, and we can do a lot of computations like this. And that's what we're going to look into. Now, what if you wanted to be more precise and actually also print, for example, the hour, the minutes, the seconds of a date? Well, this time you need to use the other main object of this datetime library. So we had date, and now we're using a datetime. So we have to do datetime.datetime. And then what follows the day is now the hours. So I don't know, let's say 14, so 2 o'clock, I don't know, minute 30 and 26 seconds. Okay, let me run this, and you'll see that now we have it displayed nicely. So that's the date, and the time that I wrote corresponds to 2 p.m., minute 30, 26 seconds. Easy. So from there, you might be wondering, can I print today's date and ask directly to print today's date? Well, yes, that's totally possible. And what we do, so since we're talking only about the date, I'm going to use the date method. And here you just put another method, which is called today. And if you run this, this will give you exactly the date of today. So indeed the same as the one I told earlier. All good. Say, for instance, you want to know not only the date, but the hour, the minute, etc. of exactly now. Well, we have to use datetime, but this time we don't say today. We use the method called now. And if I run this, you will see that you get the exact moment, the time at which I run this command. And you can see that you have quite a lot of precision. Those are seconds. So what's after are decimals of seconds. And as you can see, if I run it again, it does indeed change. Great. So this was a little introduction for you to discover and familiarize yourself with the datetime and date objects. But in general, what's going to happen is that you will have some dates in the form of strings, in a file somewhere, etc. So the point is to be able to convert those strings that you're going to get into a datetime, date or datetime format or object, so that then you can start doing manipulations. So let me show you how you can do that. So let's say we have a date. So be it in a CSV file because you're analyzing the stock market or etc. But you will be getting some dates. Okay, so to convert this, what we'll do is to use again this datetime. And here, what we're going to say to use now is a method called strp time. So strp, you understand str for string in there. So then what we have to give, let's see what this method wants first, the date string, you see, and then second, you have to give the format. So our date that we are using, that we are trying to convert is D1. And now we have to give the format. So that's where you have to explain to Datetime in how the date looks if you want. So what we have is that first we have the year. So for that we have to say %year. Then this is separated with the other digits, the other numbers, beg your pardon, which are the months. So we're putting this symbol. So then the months is %little m, small cap m. And then we have the day. So then we do %day. There we go. So if I run this, what do we see? I forgot to close the parenthesis. So what do we see now? There we go. We can see that it has converted nicely in a date that Python can handle. You see, by the way, because I didn't specify the hour, minute, seconds, it takes a default value, and that is 0, 0 everywhere. Let me show you what's important to show you is that, depending on the style of how the data has been saved, etc., how the dates, so basically how the dates are stored in the file you're using, these will differ. It won't necessarily be separated by this little symbol here. It might be separated with spaces. So if we do that like that, now we get an error and if you read the error, you understand directly what's going on. It's telling you time data, the string here, does not match the format that you've given me. And it makes sense because now the separation is a space. So all you have to do is adapt the thing accordingly. So now I'm putting spaces. If I run this, there won't be any problem. It understands the date very well. So that's great. You know, maybe you'll have slashes as backslash or front slash. I don't exactly know how you call this symbol. Anyway, same story. You just have to adapt, and you can see that, I've been changing the separation symbol, but whatever comes out is always the same thing. Is in the format that Python wants, this datetime format, and that has this symbol as a separation. Okay, so that's one simple example. But let's say we complicate it a bit more, and let's say that we actually, now what we're getting in our file is not only the date, but also an hour and a minute. So I don't know, it could be 9 o'clock in the morning, and then, I don't know, minute 50, so 35 past 9. And I choose to separate now my hour and my minute with a column. Well, what I have to do is also specify this in my strip, strp time. So separation is a space, I do a space. Now I want to give the hour, so I have to say %h. The separation symbol is a column, so I'm putting a column here. And then what I'm specifying after are the minutes, so I do column minutes. So if I run this now, you can see that it has understood it perfectly and has added this little 0, 0 for the default seconds. Great. But let's say we actually also getting the seconds. Let's say I'm putting also column 0.2. And so here, what I would have to do is do %big S. And there we go. You have the O2 that displays as well. Great. Now I want to bring your attention to another time format. And that's the one that is widely used by machines because it's very concise and very understandable for a machine. Not very much for a human, but for a machine, yes. So for that, I'll import this time library, which is also a Python native library, so you don't need to install it. And what I'm going to do is do this print time dot time and with parentheses. And if I run this, what we get is the time of now in that convention. And that convention is the timestamp epoch. And that's basically counting the seconds since 1970. So this is a very concise way of describing time. Of course, for us, it doesn't mean anything, but for machines or to write in a text file, etc., it is very simple to transmit for everybody to understand, etc. Just a number of seconds since a reference date, and it turns out that the reference is the 1st of January 1970. Anyway, so that's that. So imagine this is widely used in finance, so you will most likely get some data where the time is the time column, for example, in your data frame or something like this will be in this format. So for us to understand, we should at least see how we can convert that into something that we as humans can understand. So for this, we'll be using the datetime library as well. So let me actually copy this, or actually just cut it and just say T1, that's our time, is going to be our this timestamp. So print T1, that's what we get here. Great. And now I want to convert it into something that I can understand. So we're going to do datetime dot datetime and say from timestamp. So that's the method that we're using. So if I put T1 in here, it's going to convert this T1 into a datetime format. So let's run this. And as you can see, we have the time at which the time of today at which I'm recording now this section of the video. Great. So that's that. There's something that I want to add to this. So this was a number in seconds. Nowadays, sometimes the convention is little by little shifting a bit, especially with the rising of high frequency trading, for example. So sometimes the the timestamp that you'll get is not in seconds, but in milliseconds, because we need that precision for high frequency trading, for example. So just remember, let me simulate this. I'll just say that now the datetime, the timestamp that I'm getting is in milliseconds. Well, if you want to do the conversion, just remember that from timestamp here, this what is expecting the number in this here is in seconds. So I have to do the conversion and therefore divide by 1,000. And if I do that, you see that now I indeed have the time times 1,000, but then because I did the good convention here, I'm also getting the time nicely. Great. So that's another important format of time, the timestamp format. But let's say now we want to do the opposite, and actually we have some dates like this in the format that we understand, and for some reason we want to convert these back into a timestamp because we want to transmit the data to another computer or something like that. Anyways, so to do that, let me take this example here. And let's say that this is D1, I'm removing the print. This is what we're getting here. Well, it's actually be even more precise and just do I use a full date here and do that. So that now is the date D2 in datetime format. So I should write it like this so we understand properly. So if I do print of my D2, but this time in datetime format, we do get the date, but as understood by Python. And then we want to transform that now into a timestamp. So to do that, we simply do D2 datetime. And here we do time. We just use the method called timestamp. And then we put parentheses. And if I run this, you will see that we get back to in the format of a timestamp. Great. Please don't forget to support us with a little like, a subscription, and share this course with others. Okay, so we have seen all the major time formats: date, datetime, timestamps, and we've seen how to navigate between one another. So now, as you have guessed, we want to apply that to financial analysis. So we should explore how we can handle all of this with Pandas. So let's start directly with a practical example. So let me import Pandas first. So Pandas as PD, that's the common alias that we use for beg your pardon, that we use for Pandas. I remind you, if you don't know too much about Pandas, I suggest you watch our previous chapters. We use a lot Pandas and etc. Anyway, so what I want to do is import a file that we've looked into in the previous chapter. So that was the price market evolution of Bitcoin. And so what I'm doing here to remind you is that we're importing using read CSV. We're importing the CSV file of the Bitcoin price. And we're not only importing it, but we're also converting it into a data frame, and data frame, which is the object of the Pandas library. So let me show you how it looks like. So if we run this and put df so it displays it, we have our data frame. And you can see notably that for each period here, we have the open, high, low, close volume of the asset that was traded during that period here. So Bitcoin, and more precisely, the Bitcoin USDT pair. And what you can also see here is that we have a date here, but that we can't understand at all. And you're probably already thinking, yeah, this is in the form of a timestamp. It looks exactly like this. We could totally do something like this to just check the type. What is the type of these numbers here? So we could do df, for example, date, and then put here d type. And I'm not quite sure if I need parentheses. Oh, there we go. So we see that the type is an int 64, which makes sense. So it's a number with no decimals, it's an int. And we see that so it corresponds well. This is indeed an integer that we see here. Okay, so now the point is, great, we have the date, but we don't really understand what it is. So we want to convert it into something that we can understand. So let me actually fetch that command so I don't do any mistakes. So let's do this. Let me actually simply run all of this. So I'll put this here. Let me just comment this. And so to do this conversion, we're using the Pandas method called toDateTime. So we're saying here now, I want the date column to be equal to that old date column, so the one in the format of a timestamp, but I must also give the unit in which this column is. And this is in milliseconds. You can actually guess that because with all these zeros, it cannot be seconds, it is in milliseconds. And that goes back to what I was saying nowadays, especially in the crypto world, etc., with all this fast-paced algorithmic trading, the data is generally used in timestamps, but expressed in milliseconds and not seconds. Anyway, you can always, let me actually show. So I should probably, if we do this, then display df. And you can see that this coincides well. We see that now actually what these are is that they're the price every hour, and the first date was in 2017. If, for instance, you had put seconds here, what you would come out of this would be something completely wrong, and you would realize it straight away. Anyway, so what I wanted to also point out is that now that we've done the change, we could also check the D type, and we'll see that now it is a datetime 64 it's telling us in nanoseconds. It printed it twice because I had not removed this. Great. So anyway, that was just a little parenthesis. So you can see that the type changed, and now this is the new format of the time. Anyway, so that's great. So now the date is in something that we understand very well, but also thanks to the fact that it is in a datetime format, we will be able to do a lot of easy manipulations nicely. So let's start extracting information from these dates. Let's say, for example, we want to know what day of the week each of these days correspond to. So I'm going to add a new column, which I'll call simply weekday. And in there, I want to get that information. So I'm going to do that this is equal to df of, so the column date. And here, the shortcut in data frame for Pandas to say that this is a datetime is just dt. So we do .dt, and then we put weekday. And let me then simply run I wanted to display the data frame. So if we do that, you see that now we have our extra column that was added here, where we have a integer, but which corresponds to the day of the week. So, okay, 03 is not so understandable for us. So let me use this opportunity to show you how you can use a mapping function to convert this into something that you want. So let me come here simply and copy this mapping. So let me just do this and let me actually copy the whole thing. So if we come here, so let's first, I'm not going to put that right now. I just want to define the mapping. So the mapping, to define a mapping, you simply use a dictionary. So in this convention here, you just realize that the Monday corresponds to 0 and therefore the 6th corresponds to Sunday. And I want, therefore, to convert that into a string, and the string is the full name of the day. So 0 is Monday, 1 is Tuesday, etc. So that's the mapping. I've run it already anyways. So now we want to apply that mapping. So we're saying now the new column weekday should be the old column weekday, where I apply the mapping here. Very easy. You just do dot map and give the dictionary of your mapping. So if I do this and I actually also display the data frame, you will see that now it all makes a lot of sense. These first lines corresponding to a Thursday, and those last here correspond to a Monday. Great. So this is but one example, but you can understand from this that this is really powerful. Maybe you would have a file where you have zeros and ones, where zeros correspond to false and a 1 corresponds to true, for example. And so for you, you want to represent that with trues and false and not zeros and 1. Well, you could use a mapping. But there's so many things you can do. This is really powerful. Okay, cool. Let's carry on and do some more operations on this date. Let's say that what we want to do now is compute the difference in the date between each rows. Say, for example, that we want to check that actually the step in all the data set is the same or not, and we check that. So for this, I'll add a new column and to that data frame, and I call it date difference. So let's shorten it into date diff. Okay. So to do that, then I have to take the column date, of course, to which I will subtract the same column date. But what I need to do is shift these dates. And for that, I'll simply do shift, use the shift method. So shift, and I want to shift by 1. So I'm taking the column date. I'm then subtracting the same column date, but I shift everything by 1 step. And so that the result will give us exactly what we're looking for. Let me show you. And you can see that here we have our new column, date diff. First column, in first row, beg your pardon, we have a nat, so not a time. And the reason for that is that, well, of course, there was no row before by definition to do the subtraction. So that's why we have a nat. And then here we see that for each, we have a step or a difference that is 0 days and 1 hour. Great. But here, when we're looking at this data frame, we're only seeing the first 5 rows and the last 5 rows. Nothing tells us that maybe something could be happening in between, right? So let me use this opportunity so that we check that, and I show you another method that we can use that is called value counts. So if I run this, it's going to count, well, let's run it, and you see it actually counts the occurrences of all the possibilities that are found in this column. And what do we see? Well, we see that a majority of the steps in this date diff is a step of 1 hour. So we have practically the same number here, but we do see a few inconsistencies or changes at least. For example, quite surprisingly, we have a few where there's no time difference, which basically, so actually 26 rows where there's no time difference. So that means there has been duplicates of the same date. So, and I think we've seen that in the previous chapter, and we removed these to keep only unique rows. Anyways, you also see that there's more. There's a few rows where the difference is of 2 hours. And so, for example, that means that 1 hour was simply jumped by the thing that was recording those data. And it can go up to, for example, 1 days and 10 hours, we do have a jump in between two rows that is up to 1 days and 10 hours. So if you're doing a financial analysis, etc., these are the kind of things you need to know when you're dealing with this data set. Great. Let's now do something that will really create some added value with this analysis on our data frame and the Bitcoin market. And actually, let's say that what we have done is that we've created a trading strategy that we've automatized, for example, with a Python trading bot, something like this, and we'll be trading this strategy with a lot of money. And in this context, you probably don't want to be trading this strategy when on days when there's quite a low volume. So let's say for this exercise, what we want to get, the information we want to get is the average volume traded depending on the day, now that we've done our weekday column. So for this, we are going to use a very powerful Pandas method called group by. So what we want to group by on is the weekday. So we'll do weekday. And now, once we've done this group by, what we want to compute is the mean of the volume. So for that, we are using the dot aggregate, so in short, dot ag method. And for that, we have to give it a dictionary. So what are we doing the average on? We said the volume, and what we're doing is the average. So I'm writing now mean here. So if I do this and I'll run, you will see that we get a nice little data frame, which is giving us the average volume traded for each day. And so by volume, this directly means that on average in our data set on Fridays, an average of a little more than 35,000 Bitcoin are traded in Fridays. And you have the same for all of the days. And what do we see? There is an important information that we see here is that, well, all the weekdays, we're always more or less around this 35,000. But during the weekend, so Saturday and Sunday, we have quite a big drop. We're now down to around 2,400. So that's about a 30% drop. So what does this tell us? I mean, in the context of trading cryptocurrencies, which are traded by professionals and also individual people, retails, well, professional traders do stop trading during the weekend. So that's why we see this drop here. So this is valuable information you could use to adapt your strategy with. Now you have a solid foundation for handling dates in Python and using them in Pandas for financial analysis. You've guessed it, it's time for me to give you your exercise so you can practice. As usual, you can find this exercise at the end of this written chapter on our website. So here, what we want you to do is to do a comparative analysis on the Bitcoin volume depending when some major financial markets are open or not. The reason for this is that Bitcoin, its evolution is known to be correlated with stock markets. And so what we suggest to do in this exercise is to compare how the volume exchange on Bitcoin, if it varies depending when certain of these stock exchanges are open. So you have the European Euronext, the New York one, NYSE, and Tokyo. So basically, the whole point here is to see if the volume of Bitcoin changes when this stock market is open versus this one, etc. So you'll find here all the indication to guide you through this exercise. And as usual, at the end, you will find a suggestion of a correction. But of course, as usual as well, I recommend you try as much as you can by yourself before you look into this. Great. You now have all the tools to handle time and dates in Python. So I'll see you in the next chapter, where we're going to dive in a very interesting Python finance application. That's how to backtest a fully automated trading strategy. So yeah, see you there. Take care.